Hi, this is Group 7. This is a demo video for the final project, which we have completed more than 80% right now. So we have worked on a project called detection of bradycardia. So our app is called bradycardia app, and its basic functionality is to predict if given a ECG data file, if bradycardia is present, if bradycardia can be detected in that file or not, if it is detected or not. So I'll go ahead and open the app. As you can see here, we have different buttons which are there for different functionalities, but one thing you'll notice is that right now only the upload ECG file button is active and all the other buttons are frozen. That is because unless and until you upload an input ECG file, you cannot use any other functionality. So I'll go ahead and upload a sample ECG file which is used to test. This will take a while. So to generate the heartbeat amplitude, we used the P detection algorithms provided to us by the Impact Lab, and it was provided to us in MATLAB, and we converted the whole algorithm into Java. As you can see, it has been implemented here. Now the file has been uploaded, and I'll go ahead and click on the heartbeat amplitude button. This gives us the basic heartbeat amplitude graph, which is generated from the ECG file using the P detection algorithm. And you can see it's been generated for all the 782 data points here. Now, since we have the graph with us now, the four main important tasks for us were to implement different machine learning algorithms on this to detect if the user is suffering from bradycardia at any point in the time series. So for that, we implemented different algorithms such as SVM, knife-based decision trees, and logistic regression. You can see those as being implemented as different classes here. So for example, for SVM, we developed a custom evaluate and predict function based on the weights and biases we generated from simulating these models in MATLAB, since that was easier. So we did that. And now to demonstrate that, I'll just go ahead and click on SVM. This will make the prediction on the input file and mark the graph with red points where it feels that bradycardia is present and it detects bradycardia. So as you can see, basically all the points, lower points of the heartbeats are marked as bradycardia. And if we click on the execution time, it will give us the execution time of how long it took for the whole process. And on clicking the analysis button, we can see the false positives and the false negatives for SVM as an analysis. We can follow a similar process to demonstrate different machine learning algorithms as well. So for example, if instead I want to try another algorithm for the same process, I'll just go ahead and click on heartbeat amplitude again, and this will give me the plain graph again. Now if I click on logistic regression, it'll make the prediction. It'll take a while, and now as you can see, it doesn't do as well as the SVM, and it leaves out a lot of points in here. And on clicking on analysis, it'll again give us the true positives and the false positives and the false negatives for the file. We can follow the same process for different another algorithm like knife base. So I again click on the heartbeat amplitude and click on knife base. It takes a while to predict on the input file, and as you can see, it doesn't do as well as the SVM here. And since it predicts a lot of points in the heartbeat amplitude which shouldn't be marked as bradycardia as well. And if you might have noticed that we have a frozen button here called power usage, which is one of the tasks where we have to calculate the power usage for using this app and different algorithms. This is one of the tasks which is part of the later task before the final summation after the 80%. All in all, we've implemented different functions here like get execution time for getting the execution time, or different plot functions to plot the graphs for the different machine learning algorithms. Uh, yeah, so I think that concludes our demo. Thank you.